I am Don Johnson, and just a real brief introduction to myself because I became very, very interested in science from a very early age. Age 8, I was reading science books, and by age 10, I became a staunch evolutionist. And my Sunday school teachers and parents couldn't answer any of my questions with regard to science that seemed to conflict with what the Bible said. And I basically then dismissed what the Bible said and got into my scientific endeavors. Thankfully, God got a hold of me for completely different reasons, and I accepted the Lord at age 12. But for another 18 years after that, I continued to believe, teach, and defend the evolutionary scenarios for the origin of life and the origin of species. And it was only when I studied the science in more depth, particularly the information science, that I said, this does not make sense scientifically. So I can honestly say that it was science that convinced me that evolution doesn't work. And what is really sad today is that studies have shown that of the incoming freshman class, of the 70% of the students who come in professing to be Christians end their college careers not professing to be Christians, which is very sad. And what I found in speaking around is that most Christians, unfortunately, are scientifically illiterate, not people in this group, because you're very interested, and that's great, and I just applaud you. The thing that I'm going to be talking about tonight, the programming of life, is based on my book, Programming of Life, which multiple times hit #1 bestseller in molecular biology. Purely secular book, but it just points out the reality of programs in life. Every one of the 100 trillion plus cells of your body has literally millions of real computers and real computer programs in it. And this is the biggest chink in the evolutionary argument because of what I'm going to talk about tonight. If you understand it, you can counter many of the claims that are made and realize that they have absolutely nothing from science to back them up. And my Programming of Life book is here. I have a Programming of Life video that's available online. You can watch it. It's had over 245,000 online views so far. It's been very popular. So I'm, the 4iam.org is my Christian website. You're welcome to check that out. Anyway, we're going to be looking at the overview of the cells, computers, and computer programs and information, and what it goes into computer coding and algorithmic requirements. And we're going to be looking a little bit at some of the properties of nature for storing information as well. And then we'll look briefly at the undirected naturalism's unanswered information questions. And like I said, that's the biggest chink in the arsenal of the people who believe in evolution. First of all, we need to realize what information is. Information always involves what is called contingency. It could be something other than what it is. You flip a coin, it could be either heads or tails. That's contingency. And that is an example of chance contingency. It's not a property of physical, not a physical property, because a physical property is based on chemistry and physics, for example, that are determined by law and initial constraints. So that a property, for example, temperature normally is not an informational property. You can convert that to information, but temperature itself is not information. Chance contingency, like flipping a coin, for example, rolling a die, that is produced by random processes, and that has no functional information. Choice contingency, that's purposeful, meaningful, intentional, and that is what is needed whenever you have codes or algorithms or things that require conversion from one thing to another. That has choice contingency, and we'll talk more a little bit about that in this talk. What I have pointed out in a couple of peer-reviewed papers is that biology is really an information science. It's not a physical science like chemistry and physics, because chemistry and physics are controlled totally by the properties of the natural law and the initial starting constraints, whereas biology is controlled by the processing of information, which is what we'll be talking about tonight. A couple of interesting observations. Back in 1966, so it's been quite a while now, the mechanism of heredity by gene action is insufficient to explain the observations. This is at the inadequacies of neo-Darwinian evolution as a scientific theory. It was the only mathematical challenge to the neo-Darwinian interpretation of evolution. That was the only conference on mathematics that evolution ever had. And the reason they never had another one is because it was so devastating. The results from mathematics was so devastating to evolution that they never had another one. But no currently existing formal language can tolerate random changes in the symbol sequence. And that's precisely what evolution says happens. We have these symbols that are randomly modified, and they produce something that's better. And that has never been observed to happen. Richard Dawkins, the chief proponent of neo-Darwinian evolution, says that each nucleus contains a digitally coded database larger in information content than all 30 volumes of the Encyclopedia Britannica. That's every cell of your body. The 100 trillion plus cells of your body has in it, each one has in it, the more information than the entire 30 volumes of the Encyclopedia Britannica. That's an important thing to realize. Dawkins also said that the biology is a study of complicated things that give the appearance of having been designed for a purpose. But to him and many others, it's just an appearance. It just looks like it was designed, but it really wasn't. It was just the result of random processes. Which, of course, the Bible says, although they claimed to be wise, they became fools and exchanged the glory of the immortal God for images made to look like man and birds and animals and reptiles. We didn't create us. God didn't create us. It was evolution that created us through amoebas going into reptiles, into, more and more advances through monkeys, and finally, here we are, the pinnacle of the evolutionary process. So why do we look at life as a computer system? What you see on the screen is a computer that was designed by Charles Babbage in 1837. It was a purely mechanical computer, but that was the first computer, and Charles Babbage is known as the father of computers because of his design of that computer. Richard Dawkins, again, he says the machine code of the genes is uncannily computer-like. Apart from differences in jargon, the pages of a molecular biology journal might be interchanged with those of a computer engineering journal. The only major thing that I would disagree with is the word computer-like. That's like saying, my good friend is human-like. No, it's not computer-like. Those are real computers. And tonight we're going to be talking about real computers. It's not just computer-like. Bill Gates, founder of Microsoft, says human DNA is like a computer program, but far, far more advanced than any software we've ever created. Can you envision how believable it would be if I told people the Windows 8 operating system that's working on this computer was just the result of random processes? I don't think anybody would believe that, but yet my operating system on this computer is far, far less advanced than the simplest life form and in the computers that are in it. Life is basically the result of an information process, a software process. Our genetic code is our software. So says Greg Ventnor, whose group extracted the DNA from one type of bacterium, inserted the DNA that was manufactured to match the DNA of another type of bacterium, and they were able to start life in that new bacterium that matched the DNA that they injected, that was not the native DNA of that bacterium. And his conclusion from that was they just replaced the software, letting the computer's hardware of the bacterium read that software and then process it to form the new life form. And so his conclusion experimentally verifies that the genome, the genetic code, is the software of life. And it's read by the hardware that's based on the biological computers. So if we look at what is a computer then, the necessary and sufficient requirements of any functional computer, whether it be mechanical, biological, or electronic, is to have a memory or internal data, to have some way of instantiating a program, an algorithm, a step-by-step process to solve a problem, processing capability, and the capability to produce meaningful output. And we'll look at what that means tonight. So electronic and biological computers have multiple components. It's not a single component that makes this computer, and it's not a single component that makes a biological computer. It's multiple components. The DNA and RNA, for example, of life can store programs to be executed. The proteins can be used for processing and for communication, and each protein and cellular controls are examples of output of the execution of a real computer program. And realize that, because every single protein, and your body has like 100,000 proteins, every one of them is generated as an output of a computer program that runs. If we look at the simplified genetic code for protein construction, and this is greatly simplified, there are lots of other ways, but inside the nucleus of the cell, there are the chromosomes, and the chromosomes are wound around the helix of DNA, and the A, C, G, and T are what are known as bases in the nucleosides for the DNA, and A, C, G, and T, it's not necessary to really know what they are, other than there are only 4 of them. There are 4 bases, just like in baseball, there are just 4 bases, so it's real easy to remember. But anyway, the strand of DNA, if you stretched it out, it would be about 6 feet long. And it would only weigh about 1/trillionth of a gram. And in that, it has 6 billion bases. 6 billion of the nucleosides that have the A, C, G, and T along them. Part of the DNA is grouped into things called genes. You've all heard of genes, and the genes can often be used as a program to create a protein. A protein can be functional all by itself, or sometimes proteins have to be manufactured and then combined in a more complex structure to do more complex things. And we'll look at examples of that. So if we look at the simplified, incredible complexity of life, we can really appreciate the fact that life is really fearfully and wonderfully made, as the Psalms declare. There are 25,000, roughly, genes, and they are used to produce over 100,000 proteins. A single gene can potentially code for tens of thousands of proteins, and it's the way in which the proteins are generated that is really quite mind-boggling, with layer after layer of complexity emerging. It is, every time we peel back one layer of complexity, hoping to get at a little better understanding of something, it becomes more and more complex. It doesn't become simpler. It becomes more complex. The genome, that's the entire strand of DNA, has those 4 bases, and there's only 4 of them, and that's a digital code. The A, C, G, and T are 4 digits in the genomic code that are just like decimal digits 0 through 9, binary digits 0 and 1 for base 2. This is a base 4 code. It has 4 different digits. And the digits are stored in the DNA and in a manner that permits for self-correcting. So they can, if there's a mistake, it can be corrected. And for protein generation, they're grouped in groups of 3. 3 of the bases. So you have 3 sets of 1 of 4. So you have 4 cubed, or 64 possible codons. A codon is a group of 3 bases. And those are used to generate one of the set of 20 amino acids. Every time you look at a living organism, for example, what you're actually seeing is the proteins that are generated from the amino acids. So information that's stored in DNA is extremely dense, the highest information density of anything known at this point. If you could take 1 strand of DNA, for example, from every human being that has ever lived, all of that DNA would fit in a single teaspoon. And if you could encode books with the same information density, that same teaspoon would hold all of the information in all of the books that have ever been written. That is how information dense DNA is. Even the simplest organism has more than 150,000 nucleotides. Those are basically contain the bases. DNA, the proteins, RNA, and everything else connected with life must be fully formed and fully functional, or else you don't have life. Now, enzymes are proteins, and we'll look at the protein construction phase. We saw it in the overview just a little bit ago. But proteins are simply, one set of proteins is called enzymes. There are more than 2,000 different enzymes, and what enzymes do is take chemical reactions that are going to take place, hold them together and apply energy to that so that the reaction can go forward. The slowest biochemical reaction that is known would take 1 trillion years without an enzyme. But with an enzyme, it takes less than 1/100th of a second. So if we look at the simplified DNA translation and transcription process, we have this DNA in the helix inside the nucleus. Along the nucleus, you have the various nucleotides here, and they have the bases in them, the A, C, G, and T. The process of making proteins starts with a very large protein structure called an RNA polymerase. It goes along the strand of DNA, separates the strand, and then it creates a copy of the information along one of those strands into what is called a messenger RNA. The messenger RNA migrates out of the nucleus into the cytoplasm and into something called a ribosome. The ribosome is the computer-controlled manufacturing plant for proteins. So the transfer RNA that's floating in the cytoplasm picks up a particular amino acid from the cytoplasm. The amino acid matches the codon on one end of the transfer RNA to the codon on the messenger RNA, so that the amino acid ultimately gets added to the growing protein chain, and that's how proteins are manufactured. And proteins have anywhere from a few hundred to several thousand amino acids in them. That's what they're made out of. And this is the simplified version of how they are manufactured. But the important thing is, from our perspective tonight, is that the code that is stored in the DNA is transferred to the manufacturing plant using the messenger RNA. So messenger RNA is like a communications medium that transfers the information from the DNA to the ribosome so that the appropriate protein can be manufactured. This is part of there are many parts of this that are actually computers. The computers that are in the ribosome, for example, there's computers in the transfer RNA, and the RNA polymerase is part of a computer system that's used to generate the message. So if we look at the system, the information systems of life, what we end up seeing is that the genetic system, which is the same for basically anything that's alive, has the same 4 bases, for example, is a pre-existing operating system which natural science has no explanation for. The specific genetic program is the genome. So that just like on my computer here, I can have a PowerPoint program to display this thing that you're looking at now. I can use it to surf the web. I can use it to do word processing. I can load this computer with many different types of applications. Well, the same thing is true for life. You can load the DNA with different genetic programs for different organisms. For example, a banana has one set, a bacterium has another, a human being has another. And those are all, they all use the same 4 bases, but they're all very different. The native language is codon-based that we talked about, the set of 3 bases. And there's enzyme-based computers that read it, the code. That's the RNA polymerase, for example. The enzyme output goes to the ribosome, and the tRNA computers transfer the amino acid to the ribosome so that the amino acid can be added to the growing protein chain. So ultimately then, in every single cell, there are multiple operating systems, there are multiple programming languages, there's encoding and decoding hardware and software so that you can have codes that are hidden in there. We'll talk about that a little bit later. There's specialized communications, there's error correction and detection and correction mechanisms, and there's a whole bunch of different input and output channels for a variety of things to accomplish everything that life needs to do. But every cell is an interactive, very, very complex, multiple computer system. And that's what I'm trying to get at here, is that every single cell has multiple computers in it, and they all communicate with one another, and there are lots of different controls for the whole thing. The most difficult thing to explain from natural processes is what is called prescriptive information. Prescriptive information is a step-by-step process for solving a problem. For example, if you have a recipe to make a cake, you'll have a prescription. You follow these instructions, add the various components, mix them and bake them and so forth, you'll end up with a cake if you follow the instructions correctly. If you don't, you won't. It might be rather bad. But anyway, the DNA sequences are real computer programs. And it's very important to realize that chance and law cannot explain choice contingency. It cannot explain decision nodes. That's like saying, in my computer here, we have a whole bunch of bits that are set to either 0 or 1. All of the settings are very important. If I drop a bit, I'll suddenly end up with a blue screen or something because the thing won't work. And the same thing is true in life. If you have computer programs in life and they don't function correctly, you'll end up with garbage, and that's not good. Prescriptive information is formal, but it obviously, just like computer programs, can be stored in something physical. For example, I can store the computer program in the computer's memory. I can store it on disk. I can store it on a USB drive. I can transmit it over the internet. I can do all kinds of things with it. But the program itself is formally produced. In other words, it's a non-material thing. The information for the program is not material. It's stored in physical medium, but the programming process creates something from a mind, not from the physical interaction of mass and energy. One of the most interesting things that a nucleotide, that's where the bases are, the A, C, G, and T, it has been found that a nucleotide can be in as many as 12 different prescriptions. That's like having a 12-dimensional crossword puzzle, picking a letter that makes sense in 12 different words. That's what life does. If you ever stop to think about how complex that would be to do a 12-dimensional crossword puzzle, have it make sense 12 different ways, try it sometime. see if you can do it. But that's what life is like. It does that in many instances. Anyway, there is no rational scientific basis for blindly believing in a relentless uphill push by mere physicality toward formal algorithmic optimization. In other words, computer algorithms do not just arise from nothing. It takes a programmer to program it to make sense. And there's no scientific rationale for believing otherwise. People do believe it, but there's no scientific rationale for that belief. In fact, the Origin of Life Prize has been around for more than a dozen years now, and if you want to get rich, all you have to do is to get this prize is propose a highly plausible natural process mechanism for the spontaneous rise of genetic instructions in nature sufficient to give rise to life. That's all you have to do. Show me how the natural processes can produce the algorithms needed by all life. Do it even for the simplest life. And you can get $1 million, which when it was first offered was quite a bit of money. It's not nearly as much today. But anyway, the life itself contains many very remarkable chemicals. The DNA background, for example, is shown here with the phosphorus and then the deoxy sugar molecules here. And then the A, T, C, and G are here. Notice the A has 2 rings, the G has 2 rings, the T and the C have 1 ring. And you will always find in DNA the cross-branching between the strands of DNA. Every A will be connected to a T in the opposite branch. Every C will be connected to a G in the opposite branch. And doing so provides the distances are exactly the same for all of these bonds. Therefore, the inter-strand distance is very, very, very stable. And that's how it's used, and that's why it's used. It's a form of redundancy that the designer of this came up with so that DNA would be very stable. And the hydrocarbons are made of hydrogen, carbon, oxygen, nitrogen, and so forth. But it's important to realize that hydrogen wouldn't even exist if the strong nuclear force constant were just a little bit larger. And if it were a little bit smaller, hydrogen would be the only element in the entire universe. So it's very finely tuned. Carbon, for example, also they're stable enough so that you can have these bonds, and they can be the duplication process, for example, and the reading the RNA, messenger RNA from this, you can break these bonds to unwind it. They're weak enough to do that, but they're strong enough so that it is very stable. And it's really a remarkable storage structure. It does require twice as many molecules as one might think, because every A is connected to a T, so if you know the sequence along one strand, you also know the sequence along the other strand. So basically one of the strands is redundant, but it's redundant in such a way that you have something that's very, very stable. One of the interesting things about life is the complexity that often is there. And this is an example in a one-cell organism, a bacterium, that has a flagellum. A flagellum is a real electric motor. It has a rotor and stator and bearings and all kinds of other things, bushings, and has a universal joint and then a propeller to propel the bacterium through solution so that it can go in search of its next victim. But this is made up of 48 different proteins. Remember, each protein is the output of a real computer program's execution. So you have 48 different computer programs that are required in order to make this thing. Okay? And then once the proteins are made, they have to be manufactured in such a way that the thing will work. And this is an example of what's called irreducible complexity, because if you remove any one of those 48 proteins, it doesn't work. If it does work, you have this flagellum spinning at 100,000 revolutions per minute, but if you remove any of the proteins, it ceases to function. And therefore it has no functionality whatever, and therefore you would have, it would be a worthless apparatus that would be ridiculous to waste all the time and energy of reading those 48 different proteins, programs to generate those 48 proteins to manufacture it. And it would be lost a long time ago if that were the case. If some of the proteins, about 10 of them, are used for other structures as well, like the injection pumps to inject poisons, but more than 30 of them are unique to the flagellum. And so if you just look at those 30, for example, and figure what would be the probability of those 30 arising by chance in order to form the 30 proteins that are needed, 30 additional proteins, and that would be, the probability would be 1 part in 10 to the 5,250th power. So 1 followed by 5,250 zeros. And since there are only about 10 to the 80th atoms in the entire universe, that's not likely to happen because that is considerably bigger than that. But that's an example of how multiple computer programs can be combined, the outputs can be combined to form something functional. So some of the problems that usually are not considered by many people, particularly biologists, is a topic called biosemiotics. That's a really big word. Those are sign systems, like if you had a semaphore or coding system. Zip code, for example, is used to have a 5-digit zip code that has been arbitrarily assigned to a particular post office. So if you have a zip code, the zip code that's defined by that post office, that's where that piece of mail will go. And but there's nothing in that 5-digit code that says it has to go there. It's just a convention that is arbitrarily assigned to that post office. In a similar way, there have been more than 20 different sign systems that have been found in life. Purely arbitrary codes. The protein code that we just looked at is one of them, where the codes form, each code has a particular amino acid attached to it, and it has meaning only because that's the amino acid that's used. But there's absolutely nothing that says that's the amino acid that has to be done because of the code. It's very arbitrary. There's nothing that makes it happen that way. There's no physical-dynamic property that makes a particular set of RNA of codon codes to refer to a particular amino acid. It's also important to realize from information theory that you couldn't have, for example, like the Miller-Urey experiment that said, well, maybe the life originated from proteins, and then other things developed from that. Proteins first scenarios cannot work. Information theory will prohibit that because it is impossible mathematically to transfer from a 20-symbol alphabet to a 64-symbol alphabet. Cannot be done. Mathematically, it's impossible. And what you can conclude from that is that life's initial alphabet had to be at least as complex as the current codon alphabet. It could not have been simpler. So whenever life was first created, it was created with the same or higher complexity that you see in life now. It could not have been simpler. And that's something that is often neglected, because people say all the time, well, maybe it rose proteins first or something, and no, it couldn't happen. The other thing that's often neglected is the fact that harmful mutations limit life's existence. Currently, on average, a newborn human baby has 60 harmful mutations that are new. And that should cause extinction of the human race in less than 10,000 years. There's a Journal of Theoretical Biology paper with the title, Why Have We Not Died Out 100 Times Over, that addresses this question. But that's one of the very few papers that actually has addressed this, because this guy says there's no way that humans should still be here, because the 60 harmful mutations isn't all that many when you talk about 60 billion, but the thing is cumulative, so that every newborn human being has 60 new harmful mutations. And so what happens then is that by the time you get out 300 generations, extinction would be certain. And that's not even talked about. Every mutation causes a guaranteed net information loss in the genome. It changes the program. That's like people say, well, evolution takes place by random mutations. Well, what is a random mutation? If I have a program in my DNA and you randomly mutate it, that's like saying in my computer, if I randomly twiddle one or more bits around to get a mutation, I'll sometimes end up with a better computer program. That has never been observed to happen. In fact, Richard Dawkins said that mutation is not an increase in true information content, rather the reverse. So even Dawkins admits mutations do not add information. They detract from information. They take away information. There has never been, ever, a case of random mutations that has produced a net information increase, ever. No one has ever come up with a case where that has happened. Consequently, Darwinism is doubted by literally thousands of scientists because there is no mechanism for producing any net information increase. Now, that doesn't mean properties can't change by mutations. For example, sickle cell anemia is caused by a mutation on the hemoglobin gene that causes sickle cell anemia. And some people say, well, that's an advantage because that protects you against malaria. And it's true, the Plasmodium parasite that causes malaria can't invade the cells that have the sickle cell anemia mutation. And that's one of the reasons why sickle cell anemia is so high in a lot of African countries where malaria is running rampant, because more people live because they have sickle cell anemia than die with a malaria. So in those cases, it's better to be sick and have lower oxygen carrying capability than it is to die from malaria. So it's a selective advantage in that particular circumstance. But ask anybody in the U.S. who has sickle cell anemia, is it advantageous to have sickle cell anemia? And chances are real good they'll say no, because there's too many side effects. So the net information increase is not an increase, it's a decrease when you have this mutation. We must concede that there are presently no detailed Darwinian accounts of the evolution of any biochemical or cellular system, only a handful of wishful speculations. There are a lot of people that believe it. Natural selection is not a mechanism, it is the process by which the results of evolution are sorted. And this is an important concept. Natural selection says we have these fully functional organisms that are produced by the DNA, and the natural selection says which of those organisms are going to reproduce. That's natural selection. The ones that have the highest reproduction rate are the ones that will have more offspring for the next generation. But that is not the mechanism for evolution, and that's an important concept, because the natural selection works on a completed organism as to whether or not it can reproduce. It has no mechanism for changing the DNA in the next generation. There's no way to do it. Therefore, natural selection is not a mechanism for evolution. Evolution is the random changes in the DNA that produce the result, but there's no way to go back and change the DNA once you have the organism complete. Stunningly, information has been shown not to increase in the coding regions of DNA with evolution. Mutations do not produce increased information. The amount of coding in DNA actually decreases with evolution. And those are some important concepts, that the idea that random mutations can somehow produce better results really has no basis in science, although it's believed by many scientists. We can realize that life is indeed fearfully and wonderfully made, because the complexity of biology has seemed to grow by orders of magnitude. Biology's new glimpse of a universe of non-coding DNA has been fascinating and befuddling. The signaling information in cells is organized through networks of information rather than simple discrete pathways. It's infinitely more complex. It is widely recognized that less than 2% of the genome codes for proteins. Back in the early 70s, the other 98+% of DNA was assumed to have no purpose whatever, and beginning in the early 70s, 1971, it became known as junk DNA. The only purpose of it was to provide raw material for mutations to take place until you could randomly create a sequence that would produce a usable protein. In fact, less than 10 years ago, Richard Dawkins said creationists might spend some earnest time speculating on why the Creator should bother to litter genomes with untranslated pseudogenes and junk tandem repeat DNA. So 10 years ago, Richard Dawkins was proclaiming how ridiculous it is that creationists believe that God would create DNA with all that junk in it. And we ought to really spend some earnest time considering that, because it really is kind of dumb. However, back in 2012, after a culmination of about 5 years of intensive study over multiple continents by hundreds of scientists, 30 scientific papers were published that outlined the known functionality of 80% of the junk DNA. So DNA now has known functionality, at least of 80% of it. That doesn't mean the other 20% is junk. It means we don't know what the purpose of the other 20% is yet. But the idea that there is junk DNA has been falsified, because it is not junk. God don't make junk. But there have been many things that have been trying to replace the Darwinian theory of evolution, because, like I said, thousands of scientists don't believe that Darwinism answers the question. It does not provide evidence for what we see. And so therefore, many different scenarios are proposed. This is one of the more interesting ones: evolution by natural genetic engineering. We know from medical research that we can genetically engineer things. We can modify the DNA so that we get properties that we like. Well, Shapiro and others, but mostly Shapiro, believe that one of the traditional objections to Darwinism's gradualism has been that it is too slow and indeterminate a process to account for natural adaptations, even allowing for long periods of random mutation and selection. Natural genetic engineering, however, employs a combinatorial search process based on DNA modules that already have functionality. That's interesting. That a combinatorial search in computer programs, when you do a combinatorial search, you search all possible results and you choose one that works. And that's what he's saying happens in the cell. And he also says such a cognitive component. The cell has a mind. It can make decisions. So it says, well, if I mutate this way, this will be the result. If I mutate this way, that will be the result, and so forth down the line to all possible mutations. And then the cell, with its mind, chooses which way to mutate to produce the right result, the most productive result. That's natural genetic engineering. And if it is true, which I don't believe it is, but if it were true, one could ask, well, how did the cell get that capability? Because human genetic engineers have a mind. How did the cell get its mind? And who told it what to do? Anyway, that's one of the things that makes it very interesting in today's environment. But what science really needs to know, and I point this out in my books, for example, science needs to provide plausible mechanisms. How did nature write the prescriptive programs needed to organize life's metabolism? How did nature formally solve life's other complex problems and write those programs? How did nature develop the operating systems and the programming languages that are used in life? How did nature develop the arbitrary protocols for communications and coordinations among the thousands or millions of computers in each cell? How did nature develop alternative generation of prescriptive messages using techniques such as overlapping genes, messages within messages, multi-level encryption, and consolidation of dispersed messages? Some of those things are really interesting. For example, it has been found that some of the messages that are used in life require decoding. You all are a little bit familiar, I'm sure, with decoding of encrypted messages. Well, once the message is decoded, so you can read the message, the decoded message has an encoded message in it. So you have multiple levels of encoding. And that becomes very, very difficult to justify if all there is matter and energy. How did these things happen? Why did they work? Why do you have those things? How did nature defy computer science principles by avoiding software engineering's top-down approach that's required for complex programming? In any computer program of any significance at all, you need to design the program top-down. You'd start at the overall basis, you break it down into a lower level, then lower, and finally at the very lowest level you write the code. That's what computer science is all about. And no significantly complex program has been found to be functional unless you follow those principles. Evolution, on the other hand, says we start at the very lowest level and randomly modify that to work its way up to an extremely complex system at the top level. That completely defies anything that is reasonable in computer science. And from computer science perspective, and I taught computer science for over 20 years, it doesn't make any sense to believe that. It doesn't happen. I've never seen randomly modified programs get better or generate in the first place. How did nature produce complex functional programs without planning by randomly modifying existing algorithms? So you have these existing algorithms in a life form, and you have random mutations on it that somehow produce better programs. It doesn't happen. It cannot happen. And in case of irreducibly complex system, how did simultaneously modification of multiple such programs happen? There's no explanation for that. These are all on my website, programmingoflife.info, and they're also in my Programming of Life book. So one of the things that we need to be aware of, real quickly is that we are in a battle as Christians. In the journal Science, they were lamenting the fact that only 28% of biology teachers teach evolution like they should, and their recommended fix to me was extremely disturbing in that they said, it is recommended for those who cannot accept evolution as a matter of faith to pursue other careers. So evolution needs to be accepted not on the basis of evidence, scientific evidence. It needs to be accepted as a matter of faith. And if you can't accept evolution as a matter of faith, you don't belong as a science teacher. And they acknowledge that that will reduce the supply of teachers. And to me, that just destroys the credibility of science. And another part of our battle, Jerry Coyne wrote the problem of evolution in America, stating that is a problem because of America's resistance to evolution. It's a product of America's extreme theistic religiosity. And his solution to that is to work actively to weaken the grasp of religion on America, because obviously it's the religious people who don't like evolution, and that has caused a problem in science. And so he basically has declared jihad against theism. Realize, of course, that the U.S. Supreme Court has indicated that it doesn't have to be theistic to be a religious belief. So his belief is a religious belief, because it is a belief that all else is subordinate to, and there's no proof that it is true. But we are to be prepared to give an answer to anyone who asks you, which is part of the purpose of this, so that we can fight against these kinds of attacks. So if we look at the goals of this particular presentation, that, there are many things about the Bible where we are indeed fearfully and wonderfully made, and God created all things really wondrously. Life is filled with incredible functional complexity. Realize that Darwinism lacks any proven scientific basis and really is dead, and people are starting to acknowledge that. The Bible, however, is really reliable. It is God-breathed and is useful for teaching and rebuke and correction and so forth. That He made the world and everything in it, including all the programs of life. And there is no explanation from natural science as to how those programs and computing hardware and software could have arisen by undirected processes. So it required some kind of a mind to do it, and that's really good evidence for an intelligent designer and good supporting evidence for the God of the Bible as well. The God who made the world and everything in it, He is Lord of heaven and earth, so that we need to be prepared and realize that we're not talking about blind faith. We don't have to check our brain at the door to go to church, but realize that our knowledge on any subject is limited because we only see a poor reflection as in a mirror versus everything really as it is. But realize that the world is blind to many truths because they have exchanged the truth of God for a lie. And that is basically what it is. There are a bunch of ID references that are on my website. There are links to this presentation on the website as well. There are some useful ID references, and there's creation-based references as well. This particular talk was based on the Programming of Life book, and like I said, the book has been has had good sales, and the video that's based on this book also has had many views, and you're welcome to view that online and see if it's meaningful for you. It will help explain a lot of what I've done in a very graphic, animated manner so that you'll be able to apply what you've heard tonight. So, the questions right now, or
Thank you, Dr. Johnson.
Okay.
So we're going to take up an offering real quick. If I can get Ron and Shane to come on up front, let me go ahead and bless that with the prayers. They get up here. You guys can be preparing. With the attendance kind of low like it is during the summer, we need a little bit of additional help. While they're getting up here, let me mention that back there on the back in the book table area, every time we do one of these programs, I try to bring a number of resources that are topic specific. So there's a bunch of DVDs and books back there that are on the cell and DNA and molecular mechanisms like the flagellum and those kind of things. Dr. Johnson's book is back there as well. You can find that and catch him afterwards, and he can tell you how much those are. And he's got some DVDs back there as well. I also got a whole stack of these. If you have some kids or grandkids, I got a whole bunch of these, and you can pick one of these up for free. It's just a little sing-along CD kind of thing. If you got grandkids, if you got more than one batch of grandkids, pick up a second one. I don't care. Okay? Let me bless the offering real quick, and then we'll have a session of question and answers. You guys can be thinking of questions you want to ask Dr. Johnson. Father, we just ask you bless Dr. Johnson one more time as and his ministry and the rest of the speaking that he's going to be doing in this area over the next few days, Father. And I just ask that you bless the offering that's taken up this evening, Father, that you would let these monies that are given have a good work for you, Father. We just ask you to bless Cedar Park as well. In Christ's name, amen. All right, you guys. Amen. Okay, so I'm going to bring around the mic and. We got the house lights all the way back up, And Dr. Johnson's bio back up there on the screen. If you have a question, raise your hand. I'll bring the mic around. If not, then I'm going to assume Dr. Johnson was so good that...
Well, I could ask lots of questions.
Huh?
You can help me to give a reason for the hope that's within me. I'm daily in dialogue with evolutionists online, and one of the questions that I get a lot, or the statements I get, is that in biology it's not real computers and it's not real software. This is just a metaphor. And I argue similarly to some of the things that you've said. How can I answer that issue?
Well, I look at, so I'm a computer scientist, not a biologist. Biologists don't like the fact that there are computers in program, and they say it's computer-like or something, just as a metaphor. But the reality is, those are real computers. And I have several peer-reviewed papers, and other people have had peer-reviewed papers that bring out the fact, and you can check some of them out on my, mostly on my secular website, scienceintegrity.org. I have links to various papers that I've written and other people have written that bring the reality out more. Have you gotten my Programming of Life book? Yes. Oh, okay. The First Gene is also a very good book that goes into this a lot more depth. I have a chapter in that. It's really an anthology of various peer-reviewed papers. So that would be good. If you can get people to look at the Programming of Life video, that's another good tool. But one of the main emphases that has been fairly recent is Greg Ventnor's assertion and statement based on his experiments, the laboratory experiments that his group did, that the genome is simply software, and that has to be read by hardware. So that says it. The computers are real. They're not just like computers, they're real computers.
Can you recommend any evolutionist sources?
Well, evolutionists really have not talked about this because they have no explanation for the production of computer hardware and software. And a lot of people, they talk about probability, for example, and even if a person could randomly modify something to produce what would be a really good computer program, if you didn't have the computer hardware that would read and process that program, it would do you no good. And so it's not just the complexity of the program, but it's the hardware that also has to be fully functional in order for it to happen. And both of those, and there is no explanation for that from naturalistic sources. And they don't like to admit that. They somehow believe that, well, random processes, if you had enough time, will produce anything. They won't, no. It doesn't really matter how much time you have, you're not going to produce functional computer programs of any complexity by random processes.
Mr. Johnson, are
Yeah.
you familiar with the topic of epigenetics by any chance?
A little bit, yeah.
My understanding is it's actually, we have information content of some sort that is stored outside of the genome, outside
Of the genome,
DNA.
yeah.
Do you have, I don't know if you have any comments on that or if you
Well,
mentioned that in your
the
book.
genome, I personally believe that there's a lot more information in the epigenetics and other coding systems than there is in the genome itself even. But we haven't really, we're just kind of getting into the epigenetics. That's the code on top of the code that's outside of the DNA strand. And a lot of the things like cell expression, gene expression, and things like that are embedded in the epigenetic codes. And the epigenetic codes change throughout life, whereas typically the DNA code does not. I don't know if that answers your question or not, but I mean, if you stop and think, for example, every one of you started out as a one-cell organism. All the DNA was the same. You had only one strand of DNA. Well, two strands if they were together in the helix. But ultimately, when you reach a certain point in your development, pre-birth, the cells, you had cell differentiation. And so you had different types of cells. And each of those types of cells, like a skin cell or hair cell or eye cell or whatever, each of them would begin to reproduce and reproduce the DNA strands with the epigenetic code for that type of organ. For example, stomach and intestine and everything else has its own type of cell. But they all have the same DNA yet. But it's epigenetics that determines those kinds of things. Yeah.
So, Dr. Johnson, you made a statement that I found very intriguing,
Uh-huh.
and you said that how did nature write these programs? And you said it's more than matter and energy. And so, what is more than matter and energy? Is that mind of God, and what is it?
Programming is a mental construct. The writing of a computer program, for example, involves mind. The program is immaterial. It is not a materialistic thing. Now, it can be stored in a physical medium, which is matter and energy. So it can be stored on a disk, can be stored in memory, and so forth. But that doesn't explain the origin of the program. The program originated in a computer programmer's mind, who then figured out the prescriptive information that it would take to make that program, typed it in or spoke it in or whatever he or she did to get the program into the computer. Once it's in the computer, a program can be stored, transmitted, all kinds of things in physical medium. But the physical medium has nothing to do with the information itself. It just stores the information that it was told how to store it by some other program. Okay? Like somebody wrote the computer hardware, for example, that tells the computer hardware how to store computer bits in memory. But the bits themselves have meaning only because they're given meaning by whoever put them there. The computer's memory has no way of generating a program by itself. Does that make any sense? Clarify it or just confuse things?
The codone, you say, codes for 64 possible combinations to make 20 amino acids. Clearly, there's some duplications. Some of those combinations make more than one amino acid. Some of them are stop codones. Has there been any scientific journals or papers to say how they make that table look up? It's a language. How can it possibly have? There's almost no correlation between those three letters and this complex amino acid.
It is true. There is no physical dynamic reason for the codon codes to produce the amino acids that they do. Now, it's true that some of the amino acids are redundantly coded for. In other words, the same, different codons, different three-digit codons can produce the same amino acid in the result. But that doesn't change the fact that there is a direct relationship between the codon and an amino acid, but not the vice versa. Looking at an amino acid, for example, in a protein, you don't know what the codon was that produced it. But there are 64 different codons, but there's some redundancy as to several of the codons. And a lot of that is starting to be studied now, because I remember when I said that a particular nucleotide can be in as many as 12 different prescriptions. Well, if every time you had a particular amino acid you required a particular codon, then you would have a real hard time making that multiplicity of things. There has to be some redundancy in order for you to do that. And so part of the fact that it is redundant will allow someone who's a really good designer to design things that will produce the needed amino acid in a particular protein and use that same nucleotide for something entirely different in another prescription. Does that kind of make sense? So overlapping genes, for example, you have three codons, three bases that make up one codon, and overlapping genes says, depending on which nucleotide you start at, you produce different results. And so they have to make sense, in that case, 3 ways, but it has been shown to be as many as 12 ways. Okay. Question?
All right, thank you very much for tonight. It was lots of fun. Now, you actually almost touched on this, my question, and I wanted to actually finish this out here. Now, is conception an analogy to turning on a computer? And is it therefore a miraculous event, meaning a direct intervention by God each time? Or is conception a naturally occurring execution of a code that's already existent?
Well, conception, in human case, where the sperm penetrates the ovum and produces one set of DNA for the new human being that is being formed, that is a natural event, just like any other any animal would be. That but on the other hand, as it's very clear from Scripture, Psalms, for example, says, I praise you because I'm fearfully and wonderfully made. You knew me from the very womb. And from a scientist's point of view, for example, life begins at conception. Human life begins at conception. There's absolutely no doubt about that scientifically. The argument that is often used by some people is my body, my choice. Well, we're not talking about your body, lady. We're talking about the body of the human being that's inside of your body that has a completely different DNA than what yours is. It's a new human being. And so scientifically, there's absolutely no doubt that that is a unique human being. Yes?
Given that gene splicing is a current industry practice, they're cutting out genes from plants and putting it into animals and animals into plants, unless we have genetically modified organisms. If what we're talking about here are hardware and software, how likely is it that someday man will be able to create life?
Well, by creating life, if you went from starting from scratch, you would not, I don't believe, ever be able to do that. But if man were ever to be able to create life, that doesn't negate the argument that it took intelligence to do it. You follow? So the first life obviously took intelligence, just like any other, if you could do it now. Now, on the other hand, Craig Ventnor's group, when they had the artificial genome, they took components that were produced by living organisms, and they took sections of the DNA that those living organisms produced. they used gene splicing to splice together the things that it took to match a target bacterium that they wanted to create. So the individual components were not living. You follow what I'm saying? So it's true that they created life from non-life because the components that they used were not living. They were created by life. That group did not know what the DNA strands meant. They didn't know the programs that were in it. All they knew is they knew the target sequence. And so they created a sequence that would match the targeted genome that they were trying to create. You got the difference? They didn't do the engineering like, I'm going to do it to, make the arms longer or something like that. They did it to match something that already existed, and they had no idea what each of the nucleotides was doing. All they did was create the sequence. Okay? Once they had the sequence created, they evacuated the DNA from the nucleus of one type of bacteria. They injected that nucleus with the DNA that they created that had a different bacteria's sequence. And when they did that and did some other things to jumpstart it, it became alive. And it was a living bacterium matching the bacterium whose DNA they had created. And that's what convinced Ventnor that DNA is simply software. When you replace the program, the hardware of the cell will read that and you'll have life. Now, how much of that is possible in the future with more advanced animals and even people? I would hate to speculate. I also hate to think about. But there have been gene cloning, for example, with Dolly the sheep and other kinds of things that we can do a lot today that we couldn't many years ago. Will we ever be able to do designer genes with gene splicing and so people can get the characteristics of their offspring that they would really like to have? Maybe.
Regarding sentience, can you give me just a word definition or denotation of the similarities or differences of language and semiotics, and then if you can comment on the Jewish language having alphabet and numerals, numbers.
The similarities between language and semiotics, well, the origin of language from natural science really is not known. Languages did not start out simple and get more and more complex, let's put it that way. That languages have always been very complex. For any sign system, for a sign system to work, you have a sender of the sign. That's the generator of the code. You have a transmission medium to transmit from one to the receiver. And then you have a receiver of that sign, and both the sender and the receiver have to understand what that sign means, which is really hard to justify from like the sign systems of life. How did the ribosome know how to interpret the sign that was transferred to it from the DNA through the messenger RNA? Genesis 1, in the Word, the beginning, well, yeah, in the beginning God created, and yeah, He did indeed. Numbers and language. Oh, yeah. They have for many years, and they've... I've seen it tried with English, but not very effectively. I've also seen it done with Greek, but the numbers, there are some very interesting things with numbers, with the Genesis code, for example, that had anyway, well, that's a different subject. It is a language, yeah.
All right, guys, thank